In this video, we're going to look at integration by parts. Now, integration by parts is like the product rule for differentiation, but it's now the product rule for integration. So let's remind ourselves of the product rule for differentiation, and we'll write it in this simplified format here. If you had two functions u and v, and you wanted to integrate the multiple of them, then it's going to be given by u v derivative plus v u derivative. So we take this one here and then we differentiate this one, and that's this term here. And in the second term we do the opposite. We take this term here, which is the v, and then we differentiate the u. Now what we're going to do in order to get the integration or the integral equivalent of this is we can integrate both sides. So if we were to integrate this side here and this side here, we would get this here. So if we were to look at this here, the integral of the derivative is just going to give us back our function u times v. So we're going to have u times v times the side here, which I've just left the same. Now what we're going to do is we're going to take this term over and we're going to take this term over here. So that's going to give us the integral of u v derivative is equal to u times v minus integral v u derivative. So this here is our equation for our integration by parts. So this is how we do the integration by parts, and we're going to go through an example of using this down below. So let's say, for example, we had two functions which we are going to multiply together and then integrate. So we have the function x times sine of x. Now what we want to do is put this here in the form that we have above. So let's say, for example, the u here, we can call that the value of x. And let's say the v derivative, we can call that the value of sine x. So that means that from this u, which is equal to x, whenever we differentiate this, we're just going to get the value of 1. And from the v derivative is equal to sine x, whenever we integrate this, we'll get back to v, and this side here will give us our minus cos x. So then we can put these values into our equation above. We're going to have our u times v, well, our u is our value of x, and our v is minus cos x. So we'll have our x times minus cos x, and we'll have minus the integral of our v, which is the value of minus cos x, times the u derivative, which is a value of 1. So that's just 1 times minus cos x. So the first part of this here is going to be minus x cos x, and this here is going to be the integral of cos x by dx. So finally that's going to give us our minus x cos x, and this term here, whenever we integrate it, is going to give us our sine x, and we're going to have our constant term here. So this is an example of how to use the integration by parts. But what we're really interested in is another side of the integration by parts, which is very useful. And that is a method of rearranging a differential equation and taking the subject, which is under the differential, outside, and putting the subject that you want inside the differential. So that's a lot of words. So let's just look at a typical example here. So if we had this here, so we're going to have a function here. So let's say it's partial f by partial y derivative times this function d eta by dx all by dx. Now what we can do is we can use integration by parts to rearrange this. Now let's say we don't want this factor of eta to be inside the differential. That is, we don't want to differentiate this here. We want this to be outside. So in order to do that, we use integration by parts. Now if we went through the same process we went through above here and used this equation here on this, then we could show that this is the same as the integral of minus eta times d by dx of this term here, which is partial f by partial y derivative. And that's really what we want to be able to show in this video. So there's 3 steps here that we're going to use in order to rearrange this. One, in order to go from this equation to this equation, we make one side negative, so that's the negative. The second thing we do is we take out from the, that should say differential, so we take out from the differential, I'll just change that just now. So we take out from the differential, the value here in this case is eta, so we're taking the eta out, so it's now outside the differential. But then what we have to do is stage number 3, we have to put this term here inside the differential. So now it's going to be d by dx, and we're putting it inside this differential. So again, that should say differential. So this here is what we want to use in order to rearrange differential equations using integration by parts. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.